Hello class, welcome to Unit 3, Lesson 1. Today we're going to learn about law of sines. Your learning target for today is that you can use the law of sines to solve for a missing side or angle of an oblique triangle. So what is an oblique triangle? An oblique triangle is a triangle with no right angles. So far, in order to use our trig functions, we've had to have a right triangle in order to use sine, cosine, tangent. Now we're going to learn how to use what is called law of sines, which is involved when you do not have a right triangle. So we're going to look at oblique triangles today. So once again, just a reminder, triangles can be solved if you have 3 out of the 6 parts as long as one of the 3 parts is a side. Got to have that side. Otherwise, it could just be a similar triangle. But today we're going to look at law of sines. So we're going to be solving triangles and using this law. The way law of sines works is it does not have to be a right triangle. And the way you set it up is you do sine of the angle over the side is equal to the proportion or ratio of the other angle over its side, sine of the angle over the side. So you just need to have a pair of these. So if I have sine of A over A is equal to sine of C over C. So you can set them equal to each other and then you can cross multiply and divide in order to solve. So we're going to be looking at how to do that. There are some requirements when we are learning how to use law of sines. If you remember from geometry, angle, side, angle. So that would mean if I had an angle and then I knew this side and an angle, I can use law of sines. Okay? So if I have angle, side, angle, I can use law of sines. If I have angle, angle, side, I can also use law of sines. So angle, angle, side would be maybe I have this angle, and then this side here. Remember, you read them in the order of the information you're given. And then lastly, if I have side, side, angle, I can also use law of sines. So side, side, angle would be x. If I have this side, and let's say this angle. Okay? That would be angle, side, side, or side, side, angle, whichever way you want to think about it. So these are the 3 ways we can use law of sines. If we have the other 3 options, other 2 options, side, 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 or side, angle, side, this is a different law, and it's going to be law of cosines, which we will learn at our next class. Okay, so if you run into those, which you won't today, but in the future, those are for law of cosines. So you need to have those 3 triangle configurations in order to use law of sines. So let's go ahead and look at an example. Example 1, it says find C. Okay, it's telling me this is angle, angle, side, but you should see why. Let's look. We have angle, then an angle, and a side. That's why it is AAS. So I'm going to set it up. I need to solve for C, which is side. So you remember little letters are the sides, capital letters are our angles. So I need to find C. So what I'm going to do is I know sine of angle, we have angle B here, over little side B is equal to, and I have angle C, sine of C over side C. Okay, so sine of the angle over the side. So this is how we can set it up. I am just taking this piece for my law of sines in order to solve. So what I would have here, sine of B. So I have sine, it's always the angle, 35 degrees, over little b, which is my side length across from here. So this is little b, is 7, equals sine of C. So sine of angle C was 105 degrees, over little c. I don't know what little c is, so I'm just going to leave it as c. Then the way we handle this is we cross multiply. So I have 7 times sine of 105 is equal to c times sine of 35 degrees. And I want to solve to get c by itself. So the way I do that is I divide both sides by sine of 35 degrees. And now you can see I have c by itself, so I just need to type all of this into my calculator. So c is equal to 7 sine of 105 over sine of 35 degrees. So we would do this on our calculator. What mode must we be in? We must be in degrees, so check. I can see my degree here, but go into your mode, make sure degree is highlighted, and then I would type it in. We have 7 sine, so 7 sine of 105. We want to make sure we end the parenthesis, and then we would divide by sine of 35. And there it is. Using law of sines, I would say my side for C is 11.788. So it's approximately 11.788. And there I have went ahead and solved for side C. Okay. Let's look at another example. Okay. They gave us our triangle. It says find little b, so that means the side, if little c is 340, and the measure of angle A is 75, and the measure of B is 60. Okay, so let's see. They gave us an angle, then we have a side, then we have an angle. That's why it's angle, side, angle. And let's see, I know that tells me I can use law of sines, and I need to solve for B. So this is the one I'm trying to solve for. So let's just check. I have angle B to find side B, that's good. And then I have angle A, but I do not have side A. So that means I need to find angle C. We have two angles. We know how to find the measure of angle C. We take 180 minus 60 minus 75. When I do 180 minus 60 minus 75, I get 45 degrees. So that means angle C is 45 degrees. And now I can go ahead and set up my law of sines. I know angle C and I know side C, and then I also know angle B and I know side B. So setting up law of sines, it is sine of the angle, I'm going to say 45, over the angle for, or sorry, the side for angle C, so 340, is equal to sine of angle B, which is 60, over what we're trying to find, B, we don't know, little b. Then I can cross multiply. So once again, I have 340 sine of 60 is equal to B times sine of 45 degrees. From here, I would divide both sides by sine of 45 degrees. And then these will cancel. So B is equal to 340 sine of 60 divided by sine of 45. It's really important that you try and type this in. I know we're not in class at the moment, but please, please get out your calculator and make sure you can type it in and get the same answer. So we would have 340 sine of, what was it? Was it 60? Sine of 60. End that parenthesis divided by sine, oops, I didn't get the divide, did I? Divided by sine of 45. Which gives me that my side length is 416.413. 416.413. So that is my answer to find B. Okay, that is example 2. Example 3, a little bit different. They tell us to sketch the triangle and then solve it. So I'm just going to draw myself a triangle, and I see I have M, B, and C. So I'm going to have capital A, capital B, capital C. Remember, the angles are always capital, and then the sides across from them are always lowercase. So C, little b, little a. And then let's fill in what I know. Angle A is 42 degrees. Measure B is 95. And side C is 125. This is telling me to solve the triangle. Remember, to solve the triangle means to find everything that's missing. So let's start with our angle. That's probably the easiest thing. We're missing angle C. So a measure of angle C will equal, take 180 minus 95 minus 42. So the measure of angle C, if you do that and type it in, you should get is 43 degrees. So that's the first piece I have solved for. So now I have solved for angle C. So that is good. Now I'm going to go ahead, let's just go in alphabetical order. I'm going to solve for side A. I have all my angles, now I need a side. So it's sine of 42 over side A equals, okay, now do you guys see side B? We don't have, so I cannot use sine of B over B. I have to use my pair that I have here. So it is sine of 43 over 125. I'm going to cross multiply, so I have 125 sine of 42 is equal to A sine of 43. In order to get A by itself, I would divide both sides by sine of 43. So 125 sine of 42 divided by sine of 43. You type it in, and I'm going to write it below here. And you get that A is approximately, hopefully I typed it in right earlier, 122.642. So now I have side A. Okay, so I have all my angles. I have two sides. Now I need to find my third side. So let's go ahead and find my third side. I'm going to use my pair of A, my angle A and my, nope, sorry, I'm not going to use those because I was not given A. I'm going to use this angle and the side that I was given. Okay, this one was rounded. This is more accurate. So I'm going to do sine of 43 over 125 is equal to, now we just found A, so we need to find B, so angle B is sine of 95 over side B. Cross multiply equals B times sine of 43. And so B is equal to 125 sine of 95 all over sine of 43. That's a 125 right here, guys. So I type that in, and I get that my side B is 182.587. And there is example 3. So just to recap, so far we have covered angle, side, angle, which is like we just did, and we have also done angle, angle, side. The last one is a special case. It is side, side, angle. We call it the ambiguous case because there could be more than one triangle made. If you remember from geometry, we have side, side, angle. If you were to write this in the other order, it would spell a bad word. Usually does not make triangles be congruent. And the reason is there is possibly two triangles. Okay, so we need to talk about, well, how do I know if there are two triangles? And then how do I find the second triangle if there is another one? So if our measure of angle A, okay, is less than 90, we need to check the angle that we find. Check the angle that we find. And it's supplement. And what does supplement mean again? We've talked about supplement. It means it adds up to 180. Okay, so we need to find it, and then we need to check it with 180. So we'll talk about that in a second. So here's what we're given, triangle ABC. So I'm going to label. We got A, we have B, we have C. This is little a, little b, little c. And if I fill in everything I know, angle A is 50, side A is 10, and B is 8. Okay, so if I look, what I'm given, side, side, angle. Okay, so I need to find angle B. Okay, the reason I know I have to find angle B is I have this pair, and the only other thing I would be able to do is I can't find any C values until I have this. So we're going to find angle B. So measure of angle B is what we got to find. Okay, so this is what we're looking for. So here is how we do it. We're going to do sine of our pair we have, 50 over 10, is equal to sine of the angle. We don't know the angle, so over B is 8. Cross multiply. We have 10 sine of B is equal to 8 sine of 50 degrees. I'm trying to solve for B, so first thing I got to do is get rid of 10. So sine of B is equal to 8 sine of 50 degrees over 10. Now how do I solve for an angle? We just got done doing this. B is equal to sine inverse of all of this. 8 sine of 50 degrees divided by 10. So I really need you to type this one in just to make sure we're all on the same page. So we have sine inverse. We're in degree mode, so we already know that. Sine inverse of 8 sine of 50 divided by 10. There it is. Here's my sine value. So it is 37.795. That's my angle. Okay. So B is equal to 37.795 degrees. Okay, so there's my angle B. But here's what we need to do. We need to check the angle in the supplement. And here's why. If we think back to our unit circle, okay, we are finding an angle measurement. If I were to tell you guys that the sine was, let's say the sine is sine of 60 degrees. Do you see how it's square root of 3 over 2? Is there another sine value that's square root of 3 over 2? Yes. And is it less than 180 degrees? It is less than 180 degrees, so could I have another triangle made up with an obtuse angle of 120? I could. So what I need to do is check to see if there would be another triangle. So if I look here, triangles go to 180 degrees, so it is possible to have two sine values, okay, that are exactly the same. This is the same sine value as this one. Same thing here, okay. So let's go ahead and let's check for it. So the way we do this is we check the angle that we find and its supplement. So we say measure of angle B, it's the one we found. We take, sorry, not the measure of angle B, we take the measure and we take 180 minus our new measurement, which is 37.795. And when I do the subtraction here, I get 142.205 degrees. So what you'd have to say to yourself is if I have angle B, this would be my new angle B. If I have angle B and I have angle, who else did I have? Angle A, the measure of angle A. Is it possible to have another triangle? Well, measure of angle B for my new one would be 142.205 plus the measure of angle A. That's not changing. They told me it's 50. What does this get when you add it up? This is like 180 degrees. So is it possible to have a triangle with an angle of this value of B? No, it is not, because there's three angles. And the third angle would have to measure up to, this is telling me my third angle would be 0. So it's not a possibility, okay? I think this is, well, this is over, it's not 180, it's over 180, right? B1, 192.205. So that's only two of my angles. So if I only have two angles and it's over 180, it's very well not possible. So in this case, there is only one triangle. And so what you would say is we found angle B and this would be my angle B. And there's only one triangle. Okay. Let's look at another one. Okay. So we have, whenever it's side-side angle, that's when you have to check it. So it says sketch the triangle and then solve the triangle. So let's sketch it. We have, this one we have to solve. We're going to do it all. So we have A, B, and C. And then I'm going to label little a, little b, little c. And they tell me angle A is 43.1 degrees. And they tell me little b is 248.6. And they tell me that, so where are we at? Little a is 186.2. All right, so I look at this. I see I have angle A and side A. And then I have side B, so that means I have to find angle B. So let's find angle B. So we have sine of, I'm going to say angle A, 43.1, over side A, 186.2. And we have to set that equal to sine of B, which is 248.6. So from here, I'm going to cross multiply. It's 186.2 sine of B is equal to 248.6 sine of 43.1. I would divide both sides by 186.2. And so I have sine of B is equal to this. So to get B by itself, it is sine inverse, okay, of 248.6 sine of 43.1 over 186.2. So when I do this, I get B is equal to, I'm going to type it in. When I type it in, I get angle B is 65.819 degrees. Okay, so this would be our possible case 1 triangle. Case number 1. Let's check if there is a second triangle. Okay, so case 2. Let's check. Possible? We need to check. I don't know. So the way we check is we take the angle we got, and we take 180 minus this angle. When I take 180 minus that angle, I get what do we get? I don't have it written down. We have 180 minus 65.819 is equal to 0.181. Okay, so that's what we have. So is it possible? So right now, this would be, so this is our B for case 1. Let's see, this would be our angle B for case 2, so number 2. Let's see. So if this is angle B, I know angle A is 43.1, so I would take 180 minus 43.1 minus 114.181 to see, is it possible to have another triangle? So I'd have 180 minus 43.1 minus 114.181. And yes, I can. The angle would be 22.719. Okay, so what angle would that be? Well, if this is my new angle B, this would be my new angle C for number 2. So we have a lot going on here. We actually have 2 triangles. So let's solve our first triangle the rest of the way, and then let's go back and finish up case 2. So we're finding case 1. So I have angle B. So this is my first answer for case 1. I have 2 sides, so I just need to find my other angle. So I have to find the measure of angle C. So I would take 180 minus 65.819 minus 43.1, which gives me 71.081 degrees. So I now have measure of angle B, and C, and I have A. I have side A and side B, so I just need to find side C. So the way I'm going to find side C is law of sines. I have to use my sine of angle C, 71.081, over little c, equals, what do we got? Sine of 43.1 over 186.2. So I would cross multiply, okay? And when I cross multiply, I would have C sine of 43.1 equal to 186.2 sine of 71.081. So C sine of 43.1 is equal to 186.2 sine of 71.081. I am so sorry, it's getting so crowded here. Okay, so I would divide both sides by sine of 43.1, and I get side C from here. I get that side C is equal to 257.790. Okay? So there's my side C, here's my angle B, here is my angle C. This is all for case 1. Okay? So case number 1, these are the answers you should have gotten. And side C. Okay, so we have 71.081 degrees, and B 65.819 degrees, and then we found side C, which was 257.790. Okay, that was case 1. Then we were on to case 2. We found our B by taking the supplement of this angle. So I'm just going to write that out. We had 180 minus 65.819. So my new measure for angle B was equal to 114.181 degrees. So this is my angle B. Now I find angle C. So measure of angle C here. We take 180 minus our B value minus the original C value that they, or sorry, not the C. This is B, and now we need A. The original A value they gave us, 43.1. So if I do that, my measure of angle C, which we found earlier, is 22.719 degrees. And if I have this, the only thing I need to find is I need to still find side A, because we had A, B, C. and we had that this was 43.1 and this was 186.2, and they gave us B was 248.6. So we just found B and we found C, and now this is the last thing. We need to find little c, the side of C. So I'm going to set up law of sines. I'm going to use my side A again, so I would have sine of 43.1 over 186.2 is equal to sine of my angle C, which is 22.719, over little c, so I cross multiply. And then I divide by 719, divide by sine of 43.1. And when I do this and type it in, I get that C is 105.247. Okay, so now I've solved my triangle. I have 3 angles, they gave me 1, and then I have all 3 sides. So there's my triangle solved, and that is case 2. So the biggest thing I want you to remember with the side-side angle is that you need to take the angle that you find, okay? If you notice, it was the only time we had to find the angle, and you take 180 minus it. And then you need to check, would it be possible to make a triangle if that would be your new B value? Well, if this is my new B value, and I have to add A to it, do you guys see I'm above 180 degrees? There's no way to make a triangle, because a triangle can only be 180 degrees. However, in this case here, we found B, which was 65.819. 180 minus that value is 114. Is it possible to have a triangle that has 114 and another angle of 43.1? Yeah, the angle would be acute. It'd be 22.719, but it is possible. Okay. So you need to be aware that there could be 2 triangles, and the only time that can happen is when we have side-side angle, and that's how you can check. So here's your learning target. I will try and post some more videos on Schoology in case you want some more resources for law of sines. And here's your homework. I'm going to tell you the only 2 that I need you to check for case 2 on. Check for case number 2. Case 2. Remember that's angle, side-side angle. Sorry, don't want to say it the other way. Side-side angle. Check for case 2 is on number 10 and number 18. Every other one, you're just going to straight up solve it for what it asked for, but it's in your book. Remember, that's on Schoology if you needed to grab one of those. So please let me know if you have any questions. Otherwise, please go ahead and get started on this homework and have a good day.